Pardon.
Yeah, that's
So,
okay.
welcome everybody. My name is Mattia Salnitri. I'm going to be the chair for this tutorial. And today's tutorial speaker is Professor Wasserman. He's a professor of the software management practice in the Integrated Innovative Institute and the executive director of the Center for Open Source Investigation at the Carnegie Mellon University. So from 2010 to 2016, he served as a director of the Open Source Initiative. And previously, he was the vice president of Bluestone Software, where he led the creation of an award-winning toolkit and managed a development team working on software infrastructure and mobile services. And he also had the executive position for various startups and continuous advice startups. So a very interesting background, especially for this talk today. So his research areas include software engineering, software development environments, database management, programming languages, and human-computer interaction. So please, Tony, the floor is yours.
Oh, good, thanks. Hello, everybody. I don't know about those of you who are on the conference, but I was looking forward to being in Melbourne today. I had made plans that involved a week in New Zealand, which is a wonderful, beautiful place, and then some days in Melbourne, and then it would have been nice to see all my longtime colleagues from IFIP Working Group 8, 8.1 that I've been a member of for all these years. But as you know, that didn't quite work out this way. So so I looked at the calendar and I said, oh, good, your talk is at 1:30 in the afternoon. And you know, if it was 1:30 in the afternoon here in San Francisco, that would be great. If it was 1:30 in the afternoon in Melbourne, that would be 6:30 in the evening here, not too bad. But it's 1:30 in the afternoon in Western Europe, which means that it's 4:30 in the morning here.
Oh gosh.
So this is, how should we say, unusual. And so I was explaining this to one of my friends in India last night, and she says, well, are you going to go give your talk in your pajamas? And so I said no, because as many of you know, with Zoom calls over the past 15 months or so, people have their Zoom shirts, right? And whatever it is they're wearing underneath, they put on their Zoom shirt and they look good to an audience. But I want to show you, I'm going to stand up. I have a shirt, I have a belt, I have pants. I am, in fact, fully dressed, showered, shaved, ready to go for the day, just about 3 hours early. So with all that, maybe we should talk about open source software. Let me get out the presentation that I have, which I think is that one. All right, let's find out. Yes. You know, this is, I'm used to using
Do you
Jitsi.
need assistance?
Huh?
I think before you were sharing the screen, Tony.
Yeah.
Yeah. Okay. You can see my.
No, we
Not
cannot.
yet.
Oh. Okay. I may have to restart. I'm going to have to rejoin the conference.
Sure.
If it's
No problem.
easier, you can email your presentation to me and I can share the screen. Okay, never mind.
Yeah, so for everybody else, please wait a second while Tony will rejoin us for the tutorial. In the meanwhile, I believe Tony first. So if you have a question, feel free to raise your hands, or if it's a question you can write, just write them in the Q&A answer, and I believe Tony or me or Aika will interrupt Tony.
Okay, so now I should be able to share my screen.
Okay.
Where, there it is. All right.
Yes.
So, okay. So let's see how we're doing. So we're going to talk about open source software and information systems. Open source software is, of course, a huge topic, and we can't begin to cover all of it, but I do want to at least give you an overview and give you some pointers to some further work and a couple of things that you might be able to go read. So let's just jump right in. It looks like we have a fairly small audience, so if you have questions, you can either find a good place when I stop at the end of a paragraph and ask a question, or you can put a question in the Q&A, and the moderation team in Melbourne will get it and they will pass it along to me. So whatever works for you, we'll make it work here. Okay. So when I say open source software and information systems, what do I mean by an information system? Because there are a huge number of them. So I went to the dictionary and I actually looked up the definitions, and the encyclopedia says that it's an integrated set of components for collecting, storing, and processing data. Well, that pretty much covers everything, doesn't it? Then I went to our open source encyclopedia, Wikipedia, which, as many of you know, is built on open source software. It's built on the content management system called MediaWiki. So you can, in fact, download your own personal version of MediaWiki, run it on your own machine, create your own wiki or other thing. So Wikipedia brings in the idea of people, that people are part of an information system. So you have a system composed of people and computers that processes or interprets information. All right, well, look, it's computer processing, it's data, it's people, it's an environment in which this all works. In today's world, it's probably a global network over which people can retrieve, exchange, update information. So airline reservation systems, stock market quotations, medical information systems, just, a huge variety of things. Even my car is an information system. I have a Tesla, and the cheap one. But the, Tesla knows everywhere I go, right? It's connected. And so it's producing lots of information, I think sometimes even when my car is sitting unused in the garage, but certainly when I'm out and about. So open source covers all of this except the people and the hardware, but there is in fact a lot of work in open source hardware too. So, if you go back to the early days of information systems, it used to be like, one machine, and it would be in this room that was enclosed in glass, and it had lots of wires and electrical power, and it was on a raised floor and air conditioned and all that kind of stuff. But it didn't process very quickly, and it didn't store a lot of things because storage capacity was limited. And of course, everything was alphanumeric. The idea of video and graphics and everything that we take for granted these days simply wasn't there in the early days. You had a room that looked like this. And this actually is from some IBM presentation. And you can see that there are tapes everywhere, because tapes were how you got capacity. You really didn't get very far in computing unless you knew how to mount a tape for reading or writing, as you can see the woman in the background is in the middle of doing. So that's a different world of information systems. But a lot of what we do today, has inherited over the years from that. And what I say to people when I talk about software engineering is that all of these advances in software have been driven by advances in hardware. There's one area where there's an exception, and that is in fact open software. Because in the early days of information systems, the hardware was expensive and the software was not. The cost of people was relatively low. So people didn't put a lot of value on software. So they gave it away. Okay. And it wasn't until the mid-1960s that somebody came along and said, oh, we're going to write a program and we're going to charge you money if you want to use it. But in the early days of computing, software was free. And then we had this big era with a lot of commercial software at high prices. And now, of course, most software is relatively inexpensive, and open source is part of that. All right, so of course, today we have network computing, we have networked access to data. Here you are, some of you in Western Europe, some of you in Australia, and I don't know where everybody else is, but I'm in San Francisco. We're able to share video in real time around the world. So it presents a whole lot of additional opportunities for us. And one of the things that's important to keep in mind is that most of the software that drives that kind of networking, all of the internet infrastructure, is all open source. Okay, so you can have the same HTTP server that we're using in this video conferencing, and you can have a lot of the same graphics libraries and things that are used by the video conferencing systems and the like. So when we think about these modern information systems, we have cloud computing, right? I don't know where this program is executing. Okay, Zoom has servers all over the world. So does it matter to me where it's executing? In fact, it's probably executing in a bunch of different places, because they've probably built the software with a bunch of microservices, and one thing is executing here and one thing is executing there, and yet it's completely transparent to us. So we have distributed data, and of course, if the data is a long distance away, like on the moon, then the amount of time that it takes to transmit it and send it back, is noticeable. But these information systems allocate resources dynamically. If you use Amazon Web Services, as Zoom does, or Microsoft Azure, or Google Cloud, or Oracle, or any of a number of others, you have the ability to let the server decide how many servers does it need, how much storage does it need, and it can dynamically allocate. So with 10 people in this conference, we don't need as many resources as if 100 people had joined. So there might be more computing power required. But we're able to take care of huge volumes of data of different types. And if you look at some of the applications that are being used in machine learning and artificial intelligence, then they're part of many information systems. I can tell Zoom to make my face brighter, or to adjust the audio, and it does all those things automatically. So there we go. So the point I'm trying to make is that open source is now mainstream. It's not optional. When you go into a company and you look at the way that they build their software, most of them I mean, well above 90% use open source software, open source libraries. Maybe they don't know they're using open source libraries, but their developers do. So when you think about open source, you have to think not only about the technology of using open source, but you also have to think about the business issues, because open source comes with licenses, which give you certain rights and restrict you in some other ways. And we'll talk a little bit about that. So what is open source exactly? Is there a definition? And the answer is yes, there's a definition. There's a group called the Open Source Initiative that's been around since 1998. And the Open Source Initiative has the responsibility for approving licenses for open source. So one of the things that you'll see if we just make this definition informal, that open source is software where everyone has access to the source code for the program that you want to run. And maybe it's in a compilable programming language, you know, like Java. Java compiles to some intermediate language, or C++, which compiles into machine code, or maybe it's in Python, which is interpreted. You also have some build scripts, things like that you use ant or make or something like that for. So if you're giving away the open source, you have to give away not only the code, but also everything that's needed to run the program. And so there's a license that comes with the code, and it tells you what you can do with it. So if you're installing Windows on your machine, for example, there's actually a Microsoft license that tells you what you can and can't do. You can't make a zillion copies of the code and give them to all your friends because the license is a grant to you. And most proprietary software is that way. Some of it tells you that you can install it on 3 machines or 5, or you can use it on all the computers in your home or something like that. But in open source software, it gives you a grant for how you can use the software. The other thing that comes with the basics of open source is the idea of a community. The community might be very small, but it's a collection of people, one or more, who are responsible for making sure that that software is operational, and for maybe any documentation or help or online support that makes it available to others. So when you think about open source, it comes with some freedoms, the rights to do certain things with it. So the first thing is you can study the code. Okay, if you're using Firefox as a browser, it's open source, you can download the source code. You can look at it. Okay, and if you're a student, sometimes it's useful to see how certain functions are accomplished and how they're built. Another thing, another freedom that you have with open source is to modify it. So maybe what you want to do is to change the position of some icon on the display, or maybe you want to translate it so that instead of having to deal with American English as it's produced by the Mozilla folks in the United States, you may want it to do British English or Australian. You know, maybe you want it to say goodbye to you when you start it up. So you have that right to modify it. You have the right to use it, of course, right? And finally, importantly, you have the freedom to redistribute it. So you might take the software, you might study it, you might then understand it, make a change to it, test and run the changed version, and then say, oh, here's a new version of the software or a modified version of the software that you can use. So depending on the license that comes with your software, you may have to make your modifications visible and available to everybody, or you might not. And when we get into a bit more of the licenses, we'll say more about that. So as you may have guessed by now, or perhaps based on your own experience, open source is everywhere. In fact, before we started, I was saying to the organizers that I would rather use the open source conferencing system. There are two of them that are widely used. One of them is called Big Blue Button, and the other one is called Jitsi, Jitsi. And they work just great, right? So in fact, if you go to meet.jit.si, you can set up your own video conference on the fly with somebody, and it works just great. But here we're using proprietary software. But I wanted to make the point that there is an open source solution for video conferencing. And there's the Firefox web browser. Maybe you're using Chrome, that's proprietary. Chromium is not. Firefox is open source. Almost half the world's websites run on the Apache web server. The rest run on either Nginx or on Windows web server. Of course, Linux itself is open source and perhaps the best known solution. And about a third of the world's servers run on Linux, and 100% of the world's supercomputers run on Linux. There's a lot of databases, database management. I've listed some here. If you're doing Java development, you're almost certainly using the Eclipse programming environment and software development framework. A lot of the programming languages that people use are in fact open, and people modify them and enhance them. So you can use Python 3.9, which is up to date. You don't have to use Microsoft Office. You can use OpenOffice or LibreOffice. This presentation is actually done with LibreOffice. And it produces a file format called ODP. And LibreOffice can actually open PowerPoint formatted documents and convert them and let you save them either in the open format or back in the proprietary one. There's all kinds of content management systems. I mentioned MediaWiki earlier. WordPress is probably familiar to most of you because, again, a very large percentage of the world's websites are built on WordPress. Right? They're blogging sites and informational sites. And then, of course, there are lots of libraries for user interface. JavaScript is probably the heart of many of them, but then there are libraries that pull together a whole bunch of JavaScript solutions, so you can have very easily pull down menus and all kinds of things that are very common in today's web and mobile-based interfaces. Let me stop there for a moment and see if there are any questions or any comments. Is this all very familiar to all of you? Should I be going faster or slower? You can just put a comment in the chat and our moderators will take a look, or you can speak up.
I don't see any raised hands, so I think they're okay with the speed.
All right.
I actually have a very fast short question for you. You were talking about hardware open source. Can you tell me a bit more about this, because I was curious about this, if you have time.
Yeah, sure. So do you have a Raspberry Pi or an Arduino machine?
Okay. Yeah.
So those are examples of open source hardware, but there are a lot of other examples. People tried for a long time to make an open source mobile phone where all of the pieces and parts of the phone were open. That turns out to be difficult because you're using a lot of proprietary hardware components. But when you get down to the basics that are found in Raspberry Pi and Arduino, you'll see that there's a lot of that. But there's also something called the Open Source Hardware Association. And if you do a search on that, that'll take you to the website that gives you a lot of information. And it's the same kind of issues come up, that what are your rights with that, and how can you license it, and those kinds of things.
Okay.
Does that
Thanks.
help?
Thanks yeah, thanks a lot. So while you go on for a second, there's a question from David. I don't know if you can read it, Tony, or I can read it for you if you want.
Let me pull down. Yeah, there's a big dispute about copyleft like FOSS licenses and BS. Yes. We're gonna get to this issue about copyleft versus permissive licenses. So if you can wait a moment, we'll get to it. Okay. And if I don't get to it in the next half an hour, come back to me and we'll make sure to get it for you. It's an important question. All right, so why do we have all these open source alternatives? Well, there are a lot of reasons. And what's happened, of course, is that as more and more people have had access to more and more computing power and know more, their developers are driving it. They're writing code and they're making it available to people. When I got to the university 16 years ago, after 20 years in industry or so, the world had changed, right? At that time, open source was pretty new. Companies didn't trust it very much. There was a small community of people who, they did open source, right? The community that grew up around Linux, when Linux came out in 1991 for the first time. And so people wrote software that ran on Linux, or they wrote open source software. Then you had some events that happened. One of the ones that was really important was that IBM decided that when they built their application server, instead of writing their own HTTP server to serve web pages, they decided to use the open source Apache HTTP server. And so here you had a commercial product, an expensive commercial product that IBM was selling, and it included open source software. Well, okay. Now I ran a company in the 80s, and we put open source software, but in our commercial product, but we didn't have the kinds of millions of users or billions of dollars in revenue that IBM has. And so when they put open source software into a commercial product, it got a lot of attention. And in fact, it caused the open source initiative to be formed. It caused some of the licensing ideas to be tightened up. But the other thing that was going on is that software was expensive. If you were a developer and you wanted to develop for Windows, then Visual Studio was what you used to build Windows applications. And just the basic version of Visual Studio cost $500. And the enterprise version of it cost 2,000 American dollars per user. So people weren't very happy about that. Oracle was the leading database vendor at the time, and you paid for your Oracle license by the machine and based on the power of the machine. As the more powerful your computer, the more you paid for it. So, that could add up pretty quickly, especially because Oracle charged maintenance. So if you wanted to keep getting new versions, you had to pay for maintenance, and that was about 20% of the original cost per year. So over time, you ended up paying more for the maintenance than you paid for the software. So, there was a lot of unhappiness. The other thing that drove people was, if I'm using proprietary software and I find a bug, what happens? Well, even if I'm paying for support, I might call up the vendor and tell them that there's a problem. I might call up my salesperson and say, well, I'm not buying any more until you get this fixed. But in fact, all the control over updating and releasing the software sat with the vendor. And so if they thought that my request for a fix was important and that all of their important customers needed that fix, they'd get it done. But if they thought that what I was asking for wasn't really all that important, they'd say, oh, thank you very much for your suggestion. And, you know, a product manager would look at all the options and, you know, put an A next to some and a C next to some others, and that kind of determined what was happening. So a lot of people weren't real thrilled about this. And they said, well, you know, I know how to write a database management system. And MySQL came out in 1994. It was one of the first open source products that had both an open source license and a commercial license so that you could use it in either way. But over time, what happened is that you got a lot of high quality open source projects, and the ones that came early got better. You know, you look at the early version of MySQL and maybe it wasn't so great and so dependable and so well documented, but today, you know, it's really solid. You know, it's been around for 27 years and software that's been put to the test. The other thing that happened is that you got commercial support for these projects. So a lot of open source projects, you know, were just done by the community and made available. Maybe they were included with a Linux distribution. So when I went out and I, you know, got Red Hat Linux, it came not just with Linux, but it came with a whole bunch of applications that were also open source. And so when I installed all of that on my machine, I had not only the operating system, but I had a lot of the web support, the browser, the documentation, the office productivity tools, and more. And it got to be higher and higher quality. And there was support for it. So if it was included in that distribution, I could call somebody up or join a discussion board and get support for it. That was a big difference for a long time. Because if I was a vendor of a commercial product like Oracle or SAP, I could go to my customer and say, well, you know, you're paying because we're here to support you. We have an office that you can come and visit. You can pay for that support. You can call us at 3 in the morning if you have a problem. And of course, the open source software doesn't give you that. Microsoft was a real leader in the opposition to open source software. So if you go back and you look at what they were saying about open source 15 or 16 years ago, the chief executive of Microsoft, Steve Ballmer at the time, said things like open source is a cancer and open source is a communist plot. Well, I mean, come on. But this was their position. And in 2017, when Satya Nadella became the CEO of Microsoft, he came along and said, we're all in on open source. And they spent $7.5 billion to acquire GitHub, which is the leading environment for storing and managing millions of open source projects. So that change in 10 years shows you that transition from a tiny community of crazy people doing open source to it becoming mainstream. And the last thing that kicked it over the threshold of popularity was the Great Recession that hit most of the developed world in 2008, 2000, around there. So here were all these companies that were trying to get systems built and out there in the world. And what happened? They had no money, right? You know, they were the housing crisis and the financial crisis took away their earnings and took away the money that they had for R&D. And they said, well, you know, maybe we should do this with free and open source software. And they did. And they discovered, hey, this stuff works. So the economic Great Recession was in itself a driver of open source acceptance and use, not just by companies, but also by many governments. So if you look around the world, you'll see that some governments made it their policy to use open source software. Brazil was a leader in this. Brazil has a notion called public software. And the country's president at the time said, hey, we have a lot of smart people in Brazil, and we have a lot of good universities with good computer science departments, and we can hire those people to work for us and write software. So they did that. So, you know, if you go around Brazil, you'll see that many of the states and their administrations use public software. Whereas if you go around California, you'll see that we have 800 different school districts, and each one makes its own decisions about what systems they're going to use, and it's all proprietary. So it's a completely different way of looking at things. But, you know, open source isn't everywhere. If you look in the US government, there's some, and there's more every day, because we had organizations like the United States Digital Service and 18F that promoted the use of open source software and developed it and supported it. So, but at the same time, you have vendors of proprietary software who obviously don't want to lose their share of the business to free software. So there are a lot of places where there have been fights back and forth. And for those of you who are in Australia, you know, there are groups in Canberra and elsewhere who are, in fact, working to promote the use of open source in the Australian government. And you'll find that that's true in many other countries as well. All right, so when we talk about information systems, what are the pieces of open source that are important? Well, the first thing that comes to mind is, of course, data management. Okay. And then you need an application framework. So people for the longest time have talked about things like model view controller models of open source software, where the view, of course, encompasses all that user interface, and the controller represents the code, and the model implements the database, whatever it may be. And so the architecture of your program typically reflects that. And in early systems, all of the control, all of the computing typically took place on one server. Today, that's different. Today, you have a bunch of little programs that are providing microservices, and they may be scattered about and calling one another, using application programming interfaces and the like, so that you have the ability, in many cases, to just replace one microservice with another and do that on the fly, invisibly. So organizations have built up technology that allows them to do continuous development and continuous release, so that instead of the old way that we shipped out a tape or a disk every few months with a new version of the software, we were able to update things more or less continuously. So when you're using some web application, whether it's Google Search or Salesforce.com or any of thousands of other things, that software may get updated many different times a day. You may not see it, but there's a new version today that's different from the one that was there yesterday. And maybe you'll notice that an icon is a different color or something like that. Right? You see the same issues come up with machine learning frameworks. So lots of people, lots of organizations, researchers and the like are using machine learning, and they're using huge volumes of data to develop this machine learning, and they use a framework. So there are tools like PyTorch that are PyTorch that are widely used for machine learning and artificial intelligence. Google produced TensorFlow, which is another AI machine learning tool. And these are completely open source, right? You can take them and use them. You have all the freedoms that we talked about earlier, to study the code, to modify it, to use it, and to redistribute. A lot of the user interfaces that we get, a lot of modern user interfaces, they adjust themselves dynamically when they discover whether the program is being run from a laptop or from an Android phone or something else. And last is the idea of virtualization, virtual machines. So, you know, if you're running on some machine, you may be running on the bare hardware, but the chances are that you're not. The chances are that you're running on some operating system. And are you running on that operating system, or are you running on a virtual machine that looks like a different machine? So for example, here on my Mac, I can run a Linux version. So I can have a window that's running, let's say, Ubuntu Linux, and everything about it looks like the open source Ubuntu Linux, and it can use the same Wi-Fi and video camera and audio and features that are in the hardware. But to me, if I make it full screen, it looks like I have an Ubuntu machine running Linux. And of course, it doesn't run quite as fast when it's running in virtual mode, but you get the idea. The reason I mentioned virtualization is that cloud computing makes huge use of virtualization. When I go to use Amazon Web Services, it may look to me like I'm running on a single machine, but in fact, they may have a virtual instance of my machine or of a cluster of machines that are running on whatever operating system they're running. So they may be running Red Hat Enterprise Linux on their machine, okay, or on their servers. But maybe I didn't do my development for Red Hat Enterprise Linux. I did it for some other flavor of Linux. And so I can have a virtual machine that runs on their machine, and it's all open source, kind of all the way down to the turtles. Okay, let me stop there for a second again and see if there are any questions. I can see there's one posted here. How is security assured with open source software? Okay, this is a good question. In case of a commercial organization wanting to implement OSS, are there any potential vulnerabilities? Sure. So the whole issue of vulnerabilities, you can go, if you do a search on CVE, and that gives you information about vulnerabilities. And there are vulnerabilities in all software, right? In commercial software, as well as in open source. And the number of vulnerabilities is about the same between open source and proprietary. Maybe it's a shade less in open source. People are doing static testing. There's a company called Synopsys, S-Y-N-O-P-S-Y-S, and they acquired a company called Black Duck. But every year they do some extensive testing of source code. And if you look for, I think they did this a couple of years ago, called Coverity, C-O-V-E-R-I-T-Y. And the Coverity scan gives you data on the frequency of obvious security holes. And so it turns out, as I said before, that no code is completely bug-free, but in fact, the best open source software is of comparable quality to the best proprietary software. So the Apache web server and MySQL, I mean, these are really, really solid pieces of software that have been around for decades and that are used by millions of people in millions of applications, and that they have teams of people who are there to jump on things. So when a bug gets reported, it typically gets fixed very quickly. And these days, that's true of the leading proprietary software and the leading open source software. So, I mean, think about MediaWiki. How many people are using Wikipedia at any given moment? Oh, certainly thousands. And it's running on thousands of servers all over the world. I don't even want to talk about how much electricity it's using. If you use YouTube, everybody uses YouTube. It's generating tremendous amounts of data that are being pumped over networks around the world. Well, it turns out that the underpinnings of YouTube are mostly open source. And they were back when Google acquired them 15 years ago. So, you know, are there ways to break it? Well, maybe, but it's pretty solid. Those of you who use Netflix, which is a proprietary service, you know, the guy who led the development of Netflix service, you know, he's a really well-known open source guy. So the quality is an issue, and if you're finding something that's really widely used out there, I don't think you have to worry very much about the relative security of that. I hope I answered your question. All right. All right, no open questions. Good. All right, onward. See how we're doing on time. Well, you know, we're going to get mostly there. So when we think about data management, you know, which is the heart of any information system, we of course worry about the security of that data, the reliability of it, the robustness. And it turns out that reliability is a historic problem with data management, because data is collected from a bunch of sources, and maybe it's accurate, maybe it isn't, particularly when you get data that's coming from multiple sources and multiple people. Maybe they're using different measurements or different standards. And so, you know, a lot of work goes into what we call cleaning up the data. Once you get it cleaned up, then of course you can manage it, but the problem with the data may be before it ever gets to processing. And if you're reading about some of the fights that are going around about the voting and election data, that's really central to it. Another issue that comes up is replication of the data. So if I'm trying to run services around the world, maybe I want to replicate my data in several different locations so that I can get the one that's nearest to me as a way of improving performance. And that's something that's been around for a long time too, because you have services that keep multiple copies of the data on different servers, and you use them to pull down an image from one place or another, so that you're not sending that image, you know, halfway around the world every time. How do you scale? So, you know, as we work with Zoom, we have maybe a small audience here, but I helped run a conference a few months ago. I guess it was last year already, and they had 1,000 people online. Well, obviously they had a lot more need for the service. Okay, so Miguel asks, oh, hi Miguel, could I comment on privacy concerns of OSS? Some countries made sure their COVID tracking apps were open source. Yeah, I think that privacy is obviously an issue in data, and it's the same for proprietary software as it is for open source. The idea of proprietary of open source is that, you know, many eyes can look at the code itself, and you want to know what it's doing. And it's not just in COVID. I'm on an advisory committee here in San Francisco about open source voting, because the question came up, you know, how do you know what the voting analysis program is doing? Is it just passing along the vote information, or is it maybe looking at the data and switching votes around? I think, you know, you have, so Miguel, you're in Portugal, if I remember correctly, well, we actually wrote a paper together. So you're subject to the GDPR, which has its data privacy issues, and those apply to proprietary software as well as to open source software. So, now that you have open source everywhere, and you have open source software in your proprietary software, then the privacy issues are constant across, independent of the kind of software that you're using. I hope that answered your question. Yes, Miguel, is that good? All right, you took away the question, so thank you. All right, good questions. We also have data management issues with streaming data. The obvious example of it is video, right, with YouTube and Netflix and other kinds of things. But it's also true of financial data. And of course, there's a big concern about the reliability and the privacy of financial data because, what happens in any given day is that billions of dollars are being transacted. When you think about Bitcoin, for example, as a payment mechanism, well, Bitcoin and Ethereum and other kinds of cryptocurrencies, they're all built on open source software. And so what you have, for example, are thousands and thousands of organizations that have downloaded and are using the Bitcoin mining software. They've installed it on their own servers wherever they are in the world, and they're trying to create Bitcoin. And that's also streaming data. So you have very, very common uses of streaming data. And all of these things have open source solutions. Some of the ones that are best known for managing this, the first one that was known for managing large volumes of data was Hadoop. And Hadoop is available, it's still available from Google. You can download the non-commercial community version of it and play with it to your heart's content. But one of the things that happened was that people built a commercial implementation of it. So there was a company called Cloudera. There was another one called Hortonworks. Hortonworks got acquired by Cloudera. But there's an interesting thing going on here. If you want to just play with the software for your own educational use, or maybe for a research project inside your organization, fine, use the non-commercial version. But if you're building a company and you're building some large data management application where you need to make sure that your application is running 24 hours a day, 7 days a week, 365 or 6 days a year, then you want to have support for it, somebody you can call or a discussion or something, then you are willing to pay for that commercial support. And the commercial implementation may be identical. It may be the same code down to the line, or it may be based on the open source version with some proprietary additions. Cassandra was developed at Facebook for dealing with Facebook data. And again, you know the kind of volume that Facebook produces. It has billions of people who are using it every single day. They're posting their own personal stories. They're posting millions upon millions of photographs. They can do e-commerce. They can have live streaming. So all kinds of different data that are being used reliably in real time by people around the world. And given the fact that people are all over the world in all these different time zones, they can't afford for it to go down. When a big application like Netflix or Amazon Web Services or Facebook goes down, it's headline news, right? And if you're running an e-commerce store and you're supporting it on Amazon Web Services, and suddenly an Amazon Web Services server goes down, as it did for a couple hours the other morning, Well, it costs you money, right? Everybody kind of makes a big deal about that. So having really reliable open source data management is part of that. Graph database systems, the best known is called Neo4j. And to give you an idea, again, Neo4j has been around at least 10 years, but just last week, they took their 6th round of funding and they got a venture capital investment of over 300 million US dollars. So there's big money involved in these open source projects. Okay. PostgreSQL has, like the others, both a non-commercial and commercial version. MySQL, we mentioned, but when MySQL was out there independently, it was acquired by Sun Microsystems. Sun paid $1 billion to acquire MySQL at a time when MySQL was only generating about $60 million a year in revenue. So that was a big payday for the guys at MySQL. And then what happened is that Sun Microsystems was acquired by Oracle. So this is actually pretty funny. Here's Oracle, which is the biggest proprietary database vendor, and they also then own the biggest open source database. And so MySQL, every time somebody used MySQL, they might be taking business away from Oracle. But what happened was that some of the people who were working MySQL said, gee, we don't want to work for Oracle. So what did they do? They took the source code of MySQL. They had the freedom to do that. And they created a fork, a new version of the code. And it was called MariaDB. So MariaDB comes from MySQL, but it has a different team of people working on it. And many of the people who are working on it were, in fact, at one point, part of the MySQL team, but they've gone in slightly different directions. So now you, as a potential user, you have your choice. And they have different features. There's a big commonality. But the point I'm trying to make here is that all of these leading data management tools are open source. Sure, there's Oracle out there, and it's been around for 40 years. There's Microsoft SQL Server, and there are a bunch of other proprietary database management systems. But if I said to you, you have to build an open source software, well, you have a wealth of choices in memory systems and community ones and commercially supported ones and so on. Now, one of the things that has come up a lot recently is the idea of open data. And that's important, right? Because maybe I have all this healthcare data, or maybe like the COVID-19 case data, or the test results data. But there's all kinds of data, right? There's stock market data and sports data. And data is not code. So the licenses that we have associated with our code, the things like the Apache license or the GPL or some of these things, they don't cover data. So what we have now are licenses that cover data, and those are separate from the licenses that cover the code. So there's something that's quite new called the Community Data License Agreement, and it's supported by the Linux Foundation. So the same people who support the Linux kernel support this Community Data License Agreement. And so if we have open source software, it comes with some license. And yet if you have let's say, a set of data that you're using for machine learning, you may want to associate a license with that data, and that you might use a Community Data License Agreement, or there are a couple of other data license agreements that are out there. And similarly, the project documentation may be licensed separately. So I might write a user manual for some piece of open source software, and I might want to make that documentation available to everybody separately from the program. So, for example, if I want the documentation for MediaWiki, I can go back there on the bookshelf behind me and grab the MediaWiki book. Here it is, MediaWiki documentation. It's commercially published, and it's covered by a different license than the software itself. But if you go to look at the MediaWiki site, they've produced their own documentation, not the commercial documentation, and it says its documentation is released under the Creative Commons by SA 3.0 license. So the MediaWiki software is released under the general public license, version 2, and the documentation is released under a different license. Okay, so licensing can get complicated. It gets even more complicated when you put this in the cloud, because now you're running your software, which has its own licensing, and you're running it on machines which have their own licensing. But there's a key difference. When you're in the cloud, you're not distributing the software. So a lot of the licenses around open source software involve distribution. So when I assign the GPL license to a piece of software, what it tells me is that I'm permitted to use it, I have all those freedoms, but if I make changes to the code, I'm obligated to give the changes back to the project. They may want to use them, they may not, but it's my responsibility to provide the code. Now I can also go to the more permissive licenses. There are ones like Apache and MIT license and the Berkeley license. Many people grew up using Berkeley Unix, and it came with a very permissive license that allowed you to make changes, and you didn't have to redistribute or give back any changes that you made. So when you look at Google, for example, they took the Apache HTTP server when they started out 23 years ago, and they made a whole bunch of changes. And, you know, the Apache license allowed them to do that. So, but when you're hosting the software, in general, without getting into the gory legal details of the FARO license, but in general, you're not distributing the software. And so you don't have quite the same set of rules to play by. Because what we have is infrastructure as a service. And when we take our code and we put it up on those servers, you know, there are implementations like OpenStack, and there are tools like Node.js, JavaScript on the server side that we can freely use. And so we host all those open source applications in the cloud. Many of you may know of Salesforce.com. Salesforce.com is a leading company selling customer relationship management software and marketing tools and the like. There's a huge amount of open source software that goes into their product. Here's a good way to think of it. You start with as much open source software as you can find to provide the various services and data management and web services that you need. And now what you do as a vendor is you put your effort into building those pieces that make you different, that add value, that customers will pay for. So the idea is to write as little code as possible. and take advantage of open source. Now, this is a huge change from what we had when I was first developing software, because we had decades where we tried to get software engineers to reuse other people's code. And the whole idea of reuse, it's like, you know, a bad word. People didn't want used software. They wanted to write their own. Developers like to write code, right? This is what they get paid to do. It's what they enjoy doing. So the idea that they would reuse somebody else's code that they might not trust or something, they just didn't do that. And here we sit today, and the world is completely different, because developers have learned now to write as little code as possible, to go out there on Stack Overflow or in GitHub or in other places where there are large volumes of open source software, take the software that they can use that comes with a suitable license and incorporate that in their product. So we've gone from a situation where open source had a bad reputation to where reuse had a bad reputation using software again and again, to a situation today where, you know, that's what you're expected to do. Okay? Because if you're, especially if you're a startup, you don't want to write code. You want to get your product out there to the market, and you want to do that as quickly as possible. So all the idea around minimal viable products and the like, really expect that you're going to put in the effort to use a lot of open source and then to add your own value with your features. So Salesforce.com is a really good example of it, and it's a company that's been around since 1999, and so they've gone through a lot of generations of their product with all of this. So one of the things that's happened, and that's a big business issue today, and again, I could spend the next hour on this slide, and I won't, but the idea is that a lot of these open source data management tools in particular, things like MongoDB and Redis and Confluent, the companies that built these had a dual license agreement. They had the idea that you could use a free version of the software, but you could also commercially use the value-added version that had, we might call it freemium, but it had, or open core. It had some open source code, but it had some additional proprietary code. But what happened was this: people wanted to write their applications to run in the cloud. And so Amazon would come along, for example, not to pick on Amazon, but they would take the open source version of, let's say, Mongo, and they'd put it on their servers. And so somebody could come along and run a Mongo application on Amazon Web Services. Who would make money on this deal? Not Mongo. Okay. Because you'd be paying for the computing power and the data storage and everything. You'd be sending your money to Amazon Web Services. So the commercial open source vendors like Mongo and Confluent said, this isn't fair. And so what they did was they created new licenses. And these are not open source licenses. Okay, they're called source available licenses. That is, I can look at that source code, but I don't have the permission to resell it, redistribute it in the way that Amazon Web Services was doing it. And so there are a couple of licenses. The best known is called the server-side public license that Mongo uses. And I showed you a link there to go read about the server-side public license if you're interested. But the takeaway is this. whereas we had for a long time all these open source licenses and all these proprietary licenses, we now have this middle ground of source available licenses, and they're not open source. Okay, an open source license is something that's approved by the Open Source Initiative. So MIT and GPL and Apache and Berkeley and Eclipse and Mozilla, those are all approved open source licenses, but server-side public license is not. And if they tell you that it's open source, go back and look at those 4 freedoms that we talked about on an early slide and ask yourself, do I have those freedoms? And if I don't have those freedoms, it's not an open source license. Okay, well, I don't want to get us bogged down in licensing, but it's significant if you're building an information system tool to know what you're providing to people and for them to know what rights and obligations exist around using your software. Okay, so the same is true for virtualization. There are a bunch of different virtualization tools. People know VMware the best. VMware Workstation for Windows or Fusion for Mac OS, but those are not open source. Again, they contain a lot of open source software, and the person who is responsible for open source software in VMware has a long history going back 15 or 20 years of open source. But now the other thing that's come about is that I want to be able to put all my software together, packaged up as an application that I can deploy anywhere. And so we had tools like Docker come along that let me take all these different pieces and parts and put them together. Now, why am I concerned about that? Well, I'm concerned about that for the same reason I'm concerned about manufacturing software. I want to know what's in my application. So the same is true if you're making a car. When I'm building a car, I have a bill of materials. I have acquired different pieces of my car from different vendors and assembled them all together to create something. No car manufacturer makes all their own parts. Why it wouldn't make sense for Ford to make its own tires. Okay? Ford makes most of the parts in the engine, but other people make the tubes or the fans or the tires that go into it. So the idea of a bill of materials or supply chain has come into practice in software products. Tell me where all these pieces come from, because if I want to trace the vulnerabilities or the security, it's important to know. Example, here I'm running this piece of software and suddenly there's a report that there's a vulnerability in some piece of software. Now I want to know, am I using that piece of software in my application? So I want to be able to look at the supply chain and the bill of materials to ask that question. So there was a project called SPDX, which was aimed at being able to verify all the things. But the most important thing to look at for this supply chain is a project called OpenChain. And if you go look at OpenChain, you'll see that it's like the state of the art in terms of tracking where all the pieces of your application came from. So now here's Docker, which allows you to take all those pieces and parts, package them together, and deliver them. Okay, so it used to be that if I was taking your application, I had maybe to take this web server from one place and the database management system from another place and the web server on, and then your code and put them all together. Well, that's a pain. So what I really want to do is be able to take all the pieces and parts, put them together, and then deliver that as a finished application because then I know exactly what the dependencies are. I know exactly which pieces are in my software. Now, the next step up from Docker, and the one that's getting the most attention these days, is Kubernetes. And Kubernetes, you can think of as managing a cluster of machines running an application. Because, as we said earlier, the things that I'm using in my application may be running on a bunch of different machines. So if I'm going to really understand what my application is, what my information system is, I not only have to know what all the pieces and parts are, but I need to know where they're running. So that's the thing that helps me protect against vulnerabilities. It's the thing that makes me able to address some of these questions that you've raised about privacy and the ability to maintain the quality of the running application, not just the individual pieces and parts. Are there questions here? I know we're getting kind of into the weeds here with some of these issues about the supply chain and the bill of materials, but here's how to think about it. You've got all these pieces and parts of software. They have to all go together and you have to deliver them. Imagine that you're Boeing and you're making an airplane. Well, Boeing doesn't make all of its own parts, right? It gets the engines from one place and the wing flaps from another place. And so when you decide that you're going to get onto a Boeing 787, let's say, you want to be confident as a passenger that all the parts are well maintained and that any problems are identified. And Boeing has it as their responsibility to make sure that happens. So when they had the problems with the MCAS software on the 737 MAX that we've read about for quite a number of years now, it was part of their supply chain. In fact, the MCAS software was Boeing's own software problem. But these things come up not just in open source software, but they come up in all kinds of manufacturing settings. So when you think about how do I build the software, you think about the development organization, one of the things that's important is that you can be responsive to the need for changes. And when you talk to some of these companies that are putting together open source software or they're putting together applications, they have a lot of control over software source code, over how it gets updated, how it gets tested. So historically, we thought about development machines, and then we put things on a testing environment and test them against a set of test data. Then we put them on staging machines to make sure that the machines that we were trying it out on were identical to the ones that we were going to use on deployment. And then we put it into production. Fine, great. All right, that's a bit painful, but it increases the chances that we're going to be doing the right thing. Well, companies like Amazon and Google and Salesforce and others are updating their machines and updating their software thousands of times a day. Maybe those are minor tweaks. But when they make a change, they don't change it on every machine at the same moment. They change it here and there. So they want to try something out. Maybe it's better performance, or maybe it's a slight tweak in the user interface. Well, they're managing thousands and thousands of servers. They can try it out on a small number of servers. So they have this idea of DevOps or DevSecOps now, because security testing now plays a key role in DevOps. And if you go again and you do a search on DevSecOps, DevSecOps, you'll see that Synopsys, the company I mentioned earlier, has a recent report on it. The Linux Foundation has a recent report on DevSecOps. So Jenkins for many years has been the de facto standard for DevOps. And there's a company called CloudBees that provides commercial support for Jenkins. But all these companies that are really advanced in their use of DevOps and open source are able to do continuous integration and continuous development and deployment of their software. That's kind of become the state of the art. We see the same thing in machine learning and AI. I mentioned earlier PyTorch and TensorFlow. So you get machine learning that they build models from large data sets. In fact, there's been a lot of controversy about these large data sets. If you looked at some of the results about facial recognition software, no matter what you may think of using facial recognition, and certainly legal authorities and authoritarian governments are trying to use facial recognition to find people who are opposed to their government, for example. But one of the observations that's been made about machine learning data sets is that maybe they do really well on white people and they don't do very well on people of color. And it's been an issue in a lot of different places that, you can make bad jokes about it, that, when you take people of various races to the machine learning software, they all look alike. And so there's discrimination in the machine learning software for facial recognition. So there's been a lot of discussion around this, but it's all open source software. So you can go in and you can look at the frameworks, you can look at the code and change your data set around so that it performs better on different data sets. So we've touched on licenses and supply chains and using commercial and non-commercial versions of software. There's tons of this. And what happened was that initially you had individual pockets in companies because companies have departments that are part of business units, that are part of divisions, that are part of the company as a whole. And so you would have different groups in different parts of the company that were working independently of one another, using different versions of open source software, and it got out of hand because a lot of developers wouldn't know what their legal rights were, and the legal people at the senior level of the company, they said, what is all this open source stuff? What are these licenses? What's going into our product? So there was a need, and there is a need, for companies to get much better control over the use of that software. So what that's led to is the idea of FOSS policies. So in inventory, what software do you have? What are you using? How do you decide which open source software you use? How about individual developers? Can they work on an open source project at work and a different one outside of work? What if it's something that's competitive with what they're building for the company? Are they allowed to contribute to projects that are being managed by others, by foundations and the like? So creating all these policies is important. And what this has led to are all these different aspects of FOSS policy development. This is a whole other talk. And so we don't have time to go into it this morning, afternoon, or whatever it is where you are. But there are a whole bunch of issues, and what companies are doing, and what I get asked to help with sometimes, are setting up open source project offices. So this is a group that's typically at a senior level in the company. Maybe it reports to the legal framework. Maybe it reports to one of the senior executives. But it's a way to address all of the open source policies in an organization. Now, if you want to learn more about this policy, there's a group called the To-Do Group. And it has now become part of the Linux Foundation. But if you go to the todogroup.org, you can learn about it and what they're doing. And they're mostly aimed at companies rather than at academic research institutions and the like. But they've produced a whole set of guides. And the guides come based on the experience of a large number of companies. And you can see the list of those companies. They include companies like Facebook and Google, but they also include automobile manufacturers and cable television network companies and a lot of things, that airlines that you might not expect. But they are intended to help you put together a program in your organization that reduces the legal risk for your company in using open source software, and also helps you to establish policies about how to use open source software and how to participate in communities, and to have your own business strategy that reflects not just an individual group or department in the company, but the company as a whole, and to support that strategy. So I really recommend those guides to you if you're responsible for open source in any way in your organization, if you're distributing open source, or if you're acquiring open source. All of these issues are addressed by these guides. And so people come in and consult and help people put those policies in place. All right. And so to sum up, since we're right at 6 o'clock, we've tried to touch on a bunch of different issues for using and creating open source. There's a lot of stuff that we haven't come close to touching on because an hour and a half flies by when you're having a good time. We touched on some of the license issues. Here at the end, we talked about some of the organizational issues. But there's a lot of things for another day, right? Building and maintaining a community, contributing to projects started by others, the differences among community and foundation and commercial projects, and most importantly, development processes for open source. There's a book by Carl Fogel, F-O-G-E-L, called Developing OSS. And if you go to developingoss.org, you'll find that there's an electronic, freely licensed version of that book that you can download and look at. So if you're developing open source software, it's a really good resource. Again, we didn't have a chance to talk about that at all today, but it's out there for you to look at and learn more. I really hope that you'll feel free to come back to me. Let me give you some contact information. This, as you may recognize, is the Golden Gate Bridge, and the city of downtown San Francisco is in the background. If you see that greenish hill over on the right, I live somewhere on the far side of that hill, about 9 kilometers from downtown San Francisco, but inside San Francisco. The picture I took here was from across the Golden Gate Bridge, not in San Francisco, but there it is. So this finds me. The email address is best, but I do occasionally tweet. Most of my tweets have nothing to do with open source software. They have to do with sports or with politics, but it is there. And you can connect to me on LinkedIn and message me there. But email typically works best. I am on WeChat. I am on WhatsApp. I'm on Telegram. So a bunch of these different things. I am not on Facebook. Okay. There's a long story about that. But I have never been on Facebook, and I'm not on Facebook. So last word, the presentation was made with LibreOffice, which is open source. So we've used our 90 minutes, but there's probably a coffee break out there for people who would normally be going to a conference. And since we're all virtual, the coffee break is probably virtual. And So let me stop there. And if there are any last minute questions, I'll be glad to try to answer them for you. And otherwise, feel free to contact me afterward. Thanks a lot.
Thanks a lot.
I can go back to sleep.
Thanks a lot. Thanks a lot for the presentation. Very nice, interesting tutorial, Tony. I actually feeling that you're not on Facebook because it's not open source, right?
My what isn't open?
Facebook. You're not on Facebook because it's not open source, right?
No, actually, that's not the reason. The reason is that when Facebook was first started in 2004, the first group that could participate were students from Harvard. And then the second group that could participate were students from other Ivy League colleges, Princeton and Columbia and Dartmouth and Penn and the like. And my daughter at the time, was at the time at Columbia. And so she was in the second group that was able to use Facebook. And so she joined in 2004 or 2005. And then the third group that was allowed was anybody who had an EDU license. And so because I went to school in Berkeley, I had a berkeley.edu license that I could use. And so my daughter came to me one day and said, "Dad, please don't join Facebook," because she wanted to have privacy to post on her wall and do all the other things that people did in the early days of Facebook. And I said, "Okay, I promise I won't join Facebook."
Oh, yeah.
And that's a promise that I made in 2006. And I've kept my promise.
Wow, that's really a good promise. That's you good old privacy. By the way, again, thanks a lot. I think there's no question for you, Tony. So again, thank you very much for this very nice tutorial. And I agree, as I also thank the audience, and thanks also Aika. And thanks a lot, Ben. And talk to you soon, maybe in the next coffee break or in the next session. Thanks, everybody.
Right, good. And I look forward to meeting the CAiSE community next year, unfortunately in Belgium rather than Oz, but we'll make it work. Take care, everybody, and